Hello, ladies and gentlemen. I'm Michael Dietrich from Lexler and I welcome you to the virtual workshop present by Lexler and Prevail Technology. The topics today is New Energy Training and Skill Development for TVET and STEAM. The meeting will be held from the development team of Lexler. I'm happy that Mr. Dr. Dmitry Kushnikovsky will attend the meeting, and also Mr. Ronald Hübner, our product manager, and myself, I'm the CEO of Lexler, Michael Dietrich, would like attend the meeting. Now I give a short speech to our partner in Thailand, our friend Komet Yulakarin.
สวัสดีครับผมโกเมศยุรคลินครับผู้แทนจำหน่ายเล็กโซล่าชุดทดลองพลังงานทดแทนจากประเทศเยอรมนีในนามของบริษัท Prevail Technology Alliance ยินดีที่จะนำเสนอชุดทดลองการเรียนรู้ทางด้านพลังงานทดแทนนี้ให้กับสถานศึกษาต่างๆของประเทศไทยครับขอบคุณครับ Thank you.
Next slide, you can see our team of Lexler, and you can see that we are a very young company established in the year 2003 as a spin-off of the Technical University of Dresden. Up to now, we are the leader for new energy training products in TVET and STEM products. In more than 60 countries with more than 50 partners, we focus in a new energy education solution around the world. But why we should invest in new energy training? I have here a short slide with some pictures about our home province, Saxony in Germany, and you can see how the province changed in around 40 years from 2018 to 2020. In 2018 we was already a carbon-based economy with a lot of lignite coal minories, and up to now we invest a lot of green energy technology, and you can see the pictures on the right side with a lot of windmill farms and solar farms in our area. But what is the next most important advantage of green energy technologies? That are the jobs what you can create with this kind of technology. In this slide you can see the job rate in the year 2020 with globally around 12 million jobs in the green energy technology. And what we expect is that we would like have in the year 2030 around 30 million jobs in green energy technology. Not only in the solar and photovoltaic business, also in biofuels, hydropower, wind energy, solar heating, but also biomass and biogas. And the potential is huge. In this actually slide you can see the Asian energy supply by fuel types. And the carbon fuel types, of course, at the moment dominate the situation. With more than 90% for oil, natural gas and coal, we have a huge potential to change to new energy technology in the next 40 years. What is the situation just now? Lexler, of course, already established in Thailand with our partner Komet Yulakarin. You can see here some pictures of our activities. Of course, we don't eat only ice cream, we also invest in trainings and make a lot of projects in Thailand already. With an example on the right side, with technical colleges in Bangkok to use our electric mobility instructor, but also on the left side with some students to join a training based on Prevail Technology to learn more about wind energy in a STEM education. Now I would like to give the floor to my colleague, Mr. Dmitry Kushnikovsky, and he would like to go a bit more deeper in the different products in our product range.
And on behalf of the Lexler, I would like to thank you for your participation. In this part, I want to show you some of our products in the field of renewable energies. Let us actually imagine the ideal world independent of fossil fuels. At this time point, it still may be far, far away and look a bit sketchy, but this day will eventually come. And we at XLR also believe in it, and therefore we also made our commitments toward it by creating several experimental systems to teach students renewable energies. We cover most of the renewable energies available, starting from the solar energy, thermal energy, wind energy, biofuel, bioenergy, as well as energy storage technologies and energy distribution by using smart grids. We have several product lines which are optimized for students of specific age, starting from the elementary school up to the middle school and high school, with our product lines of basic, large and ready to go. However, we also have some products which can be used for higher education, like teaching in universities, as well as for technical, vocational and educational training. So today I want you to present XLR Professional series, which are a complete experimental kits which allow performing a broad range of experiments on the laboratory scale. And each kit already includes all necessary ancillary equipment which are required to set a solid both theoretical and practical background for the students. So the professional series is suitable for the level 3 up to 6 according to the International Standards Classification of Education, and can be applied for teaching pupils at high school, students in the first or second year at universities, and for technical and vocational educational training. But please also note that not just our professional series, but also some of our products in a ready-to-go series can also be used for such a purpose, like XLR biofuel ready-to-go or bioenergy ready-to-go, as well as XLR hydrogen ready-to-go. And depending on the experimental kit, between 5 to 40 different experiments can be performed. Okay, we will start with solar energy. As Michael already mentioned, solar energy is responsible for around 30 to 40 jobs created in the new energy sector. It's also one of the most technically developed branches of the renewable energies. The new types of solar cells are constantly being developed with a higher and higher efficiency. For such case, XLR also created one of our products dedicated to the solar energy, and it's called XLR PV Professional. The experimental kit is designed to be equally used for training of the sales personnel, for apprenticeship, as well as for pupils in the high school, students at universities. It covers several topics, from basic physics experiments up to more and more complex experiments in both electrical engineering as well as photovoltaics. But the main focus is, of course, on the laboratory systems and on construction of your own photovoltaic setup of a tabletop size. Let's have a look what's included in such an experimental system. As you can see, all of our systems are supplied in such aluminum case, which is quite practical and can be used almost elsewhere, thanks to all the ancillary components included in this case. Also, due to the modular setup and the very specific characteristics and functionality of single components can be analyzed, such as, for example, a switching threshold of the series or a shunt regulators, as well as the functionality of the PWM or a pulse width modulator. There is also included a DC-AC inverter, deep discharge protection, as well as other modules. And with the help of all of these modules, a total of 34 different experiments can be performed. Besides the hardware, all kits also include both teacher and students manual with detailed experimental procedure, and also some of our products, like for example the Mpp, also includes a colloquium which is specifically tailored and designed to help students and teachers in the educational process, going step by step from the basic physics experiment to more advanced, while demonstrating the practical application of the solar cells and the photovoltaic setups of the both off-grid and on-grid solar systems, and up to building a photovoltaic setup in a laboratory scale and a simulation of the different real-life scenarios. And now my colleague will demonstrate you some of the functionality as well as some of the experiments of PV system.
Hello ladies and gentlemen, let me introduce you to the Lexolar Preview Professional system. So I open the experimentation kit. You see we have all different kinds of modules in here, consumer modules, regulating modules, potentiometer in here. I will show you some of them in detail shortly. For start, I want to show you how the experimentation kit works in general. All Lexolar experimentation kits work with these base units. The base unit you can just drag and drop the modules on and can build up your experiments. Here I have a so-called power module. Power module is functioning as a power distributor in all of our experiments. I can regulate the voltage coming in from 0 to 12 volts, and I will plug in some resistor modules. You can see some resistors here are connected in a parallel connection, and I need a consumer for my little demonstration experiment. This is a propeller. And now I will close the electrical circuit with these short circuit plugs. And of course I need some power. And as you can see now, all the modules here, and I can start the experiment and the motor will start spinning. So, okay, now for the next experiment I will show you the parallel and the series connection of solar cells and the difference between. For starters, we have here these solar cells. Single solar cell capable of 0.5 volts and 420 milliamperes. I will now place this solar cell, these 3 solar cells I have here, in a series connection. There's a series connection. And again, I will use my short circuit plugs. Close the electrical circuit. Now I have a closed electrical circuit, and we will take a look on the back of the Lexolar base unit. You see here the power lines where the electricity can flow, and now the power is flowing from the solar cells into the motor module. Here are the solar cells. Means solar cells are connected in a series connection and will close the circuit. As you can see, I have not enough light here in my office, and for that purpose we have these light modules. There are small light bulbs in here, and with these light modules and my Lexolar power module, I can illuminate each single cell. Again, here I have a power module, and as you can see, as I turn on the voltage, the light bulbs shining brighter. And now I want to illuminate every single solar cell. For this purpose I have 2 additional light modules, and I will connect them to the power module. So, as you can see now, to the camera, all 3 connected to the power module, and now I will illuminate the solar cells, and you can see motor module is running. So this is again a series connection for the cells. So if I shade the middle solar cell, and so middle one is shaded, so I have a disconnection in the electrical circuit by this solar cell, and so the electricity cannot flow and the consumer is not running. And the difference is when I connect my solar cells in a parallel connection. I will show you. I just turn the solar cells by 90 degrees. And switch the electrical circuit. Now the solar cells are connected in a series connection. And if I illuminate them, you see already the motor module is spinning again. And by shading the middle solar cell, I'm not disconnecting the electrical circuit. Yeah, the other 2 solar cells are enough to power my motor module, but in average the voltage is not added up like in a series connection, so the motor module is not spinning so fast. So this is the main reason why in solar power plant the solar modules, the single solar modules, are connected parallel and in the series connection. So when a leaf or a cloud or something is shading parts of the power plant, yeah, the rest of the power plant is running. So for my next experiment I want to change my setup. We will use this solar module, which consists of different solar cells and a series regulation. And I will use this. And this will be illuminated by another light module, which is also included in the PV Professional. I will illuminate my solar module, and I want to check what voltage and what current is given me by the solar cell. I will check it with this AV module, which is measuring the voltage and the current in my electrical circuit. As a consumer module I have this light bulb, and I will close the electrical circuit, and as you can see I will illuminate the solar cell and the light bulb is shining. Now we are around 3.8 volt and 130 milliamperes, and this is obviously enough to illuminate the light bulb. But it's not the maximum power drawn. Yeah, the electrical power is the product of the voltage and the current in the electrical circuit, and we want to find the point where the power is at its maximum. This is the maximum power point. Finding this, we need the Mpp Tracking Module. The Mpp Tracker is a DC-DC inverter which converts the incoming voltage and the outgoing voltage, and I can regulate this with the Mpp Tracking Module. And when I switch up a bit. Need to close the circuit. You see, I can regulate the incoming and the outgoing voltage and therefore regulate the illumination of the light bulb. And by doing this, I can find the point where the voltage, the product and of the voltage and the current is at its maximum. And this is the so-called Mpp. And I want to find the Mpp to compare different solar modules and solar cells with each other to see which one is the best.
Okay, thank you, Roland, for the demonstration. And we'll be moving to the wind energy. Wind energy still occupies the top place in terms of the amount of generated energies among all of the renewable energy sources and technologies, and still has a great potential due to its high efficiency. You can imagine how effective it is, in fact, just by knowing that some countries like Denmark, for example, on a windy day can completely supply itself just from the energy generated from the wind energy sources and wind plants installed both onshore and offshore. Its high efficiency makes it really attractive, and that's why a lot of the medium-sized wind farms with installed capacity of 50 to 20 megawatts are currently being installed all around the world, with up to some real giants like Gansu wind farm, which has an installed capacity of 8 gigawatt with a planned up to 20 gigawatts. So, and our product in this field is called Lexlar Wind Professional, and it's designed to teach students some basic fundamentals of the wind energy and wind energy generators, also to show them what parameters they need to keep in mind while designing their own windmill, how these parameters influence on the total efficiency. So, for example, they will get an understanding, and they will really understand how the choice of number of blades as well as the rotor, so blade rotor geometry influence on the total efficiency. They will also compare horizontal rotors with the vertical rotors, and the horizontal rotors, for example, can be used in really harsh conditions, really harsh weather conditions, like oil platforms and things like that. But what's most critical is that they will really understand how these parameters influence on the total efficiency of such systems. Now my colleague will also show a couple of experiments from the Wind Professional.
Okay, let's talk about the wind technology. In our Wind Professional system, we have different options of investigating how the technology works, which converts the wind energy into electric energy. Key component is this turbine here, and this is a small electric motor, and with this turbine I will do now a small experiment. Again, we need our Lexlar base unit for this experiment. I will place my turbine here. Okay, now what we want to do is build up our own rotor for the turbine. In this system I have the possibility of using two different types of blades and also a different number of blades. I will now choose a standard rotor with 3 blades with a pitch angle of 25 degrees. So I can build up my rotor with ease like this and place it on my turbine. As a consumer, I will take this motor module, and now we need some wind. The wind comes from this wind machine, which is able to create a laminar airstream onto the wind turbine. I will place it on my base unit, and I can power it again with the Lexlar power module. And the Lexlar power module obviously operating again from 0 to 12 volts. And as I'm changing the incoming voltage on my wind machine, I can change the wind speed of the wind machine. And I will demonstrate it to you. I will just power up and start the experiment. Now I want to talk about all the possibilities you have experimenting with the Wind Experimentation Set. Again, the setup with the wind machine. Here I will place my wind turbine, and this little propeller here works as my consumer. Instead of the consumer, I could also use this AV module, which tracks the voltage and the current, and from that I can calculate the power given me by the wind turbine. But for this experiment I will use my motor module so you can see some differences. So the first parameter I can alter with my experimentation set is the wind speed. I already told you this is a power module powering the wind machine, and I can alter the voltage into the wind machine by using the power module from 0 to 12 volts. And as I'm going up in the volts, the wind speed coming from the wind machine will go up too. I can measure the wind speed with this aerometer here. This is our aerometer. See, it has a little propeller here, and as I blow up into the propeller, you see the wind speed is measured. So I'm placing this here where the wind turbine will be, and alter the wind speed by the power module, and I can measure the wind speed, so I can correlate the wind speed and the incoming voltage. So now I've measured my wind speed. I can set up my wind rotor. And again, this turbine, place it here. And these are the two types of blades I can use, a triangle one and a quadrant one. And again, I can build up my rotors with this kit I have here. I can build up a 3-angle rotor with a triangle shaped blades. I will place it onto my wind turbine, and I will run my experiment from now with 10 volts. And as you can see, the electricity is high enough, or the power is high enough, that the consumer is working. Now I will alter the shape of the blades, just putting the triangle ones away, and try out the other blade shape, again with 3 blades. Yeah. Place it onto my turbine and run the experiment. Obviously the power again was high enough for me to run the little propeller. So now I have altered the wind speed and the shape of the blades. I will now alter the number of the blades. I have another kit here, so I can put in 4 blades. Yeah, this is changing the number of the blades. And can run my whole experiment with that again. So I even can go and make some fancy experiments here For instance, I can only use 2 blades and build up my rotor and see what happens. It's still enough with 2 blades at this wind speed. And I can even try one blade. And as you can see, I've now altered the wind speed, the shape of the blades and the number of the blades. And for now, I can also alter the angle of the wind turbine itself, as you probably notice. And now the wind comes directly from the front, and I can just switch it to the 90 degrees angle, and you see the wind comes from the side. The rotor is not active. So this is the angle of the turbine. Now I can alter the pitch angle of the blades. You see, I use 25-degree pitch angle, and now I can use some other pitch angles. For instance, I have here a 90-degree pitch angle. Alter the pitch angle, try again, what happens? And you see, with the 90-degree pitch angle, the rotor, the wind is high enough for the rotor to operate, but the power which is produced is not high enough to power up my consumer. And at last, which I want to show you, is I can also play with the alternate axis of the wind turbine. Here I have a horizontal axis, and in comparison to that, I have a Savonius rotor with a vertical axis. This is the Savonius rotor with a vertical rotation axis. So here you can see, with the Savonius rotor, I don't care from which angle the wind blows. This will rotate, but the power is not high enough to operate my consumer. So with the whole experiments, I want to show you that I can alter one parameter, which means wind speed, angle of the wind turbine, the pitch angle. I can alter the blade, the number of the blades. I can alter the shape of the blades. And with all these different parameters altered, I can calculate with the AV module again. I can calculate the power given me from my wind turbine and can see what constellation gives me the maximum of power. And this is how we want to show you how the wind technology works.
Hydropower is one of the ways how we can convert the kinetic and potential energy from the water sources into the electrical energy. It's also one of the most efficient ways how we can generate water from the renewable energy sources, and it doesn't really fall back from the wind energy in terms of the amount of generated energy due to its high efficiency. Our product in this field is called Lexolar Hydropower Ready to Go, and it's a complete experimental kit which is designed to teach students the basics of how we can utilize the hydropower plants in our life. The students can simulate several scenarios. They can also simulate the water dam, they get some understanding of the basics of the hydrodynamics. They can create some dependencies on the fall height and the efficiency of the power plant. They can also follow the historic developments of the water generators and the water turbines, starting from the simplest water wheel, which are being used for centuries in water mills, moving to the more complex cross-flow geometry and ending up at the most complex geometry, which is called a Pelton turbine, which is currently also used in real power plants. And our next product is called the Lexsolar Thermal Energy Professional, and it's a product which is dedicated of using a concentrated solar power. So unlike the photovoltaics, a concentrated solar power doesn't really directly converts the solar radiation into the electric energy. Instead, we first of all convert the electric energy into heat by heating, for example, water or any other liquid, which later can be used in the turbines and generators by spinning them and therefore converting its mechanical energy into the electricity. It's also one of the ways how we can heat residential areas, for example, in the countries which do not have a conventional heating system or a centralized heating systems. In such experimental kit, there are also several elements of interest that are included, like students can use CSP technology or concentrated solar power, LTA element. Another main feature of the experiment, of this experimental system and experiments is regarding the basics of the thermodynamics, heat absorption, heat radiation, as well as convectional flow. And this experimental system provides a comprehensive understanding of the applied physical effects. Our next product is called the Lexsolar Thermal Energy Professional. And this experimental system allows for the application of different technologies of solar thermal energy transformation. So unlike in photovoltaics, where the solar radiation is directly transformed into the electricity, in this case we first of all need to transform solar radiation into the heat by heating, for example, water or any other fluid, and with the later using of it in the steam engines to convert it to the electricity. This experimental system also allows students to get some understanding of the basic thermodynamics, get them familiar with the concept of heat absorption, reflection, also conduction, heat conduction, convention, and so on. It utilizes such components as, for example, CSP technology or concentrated solar power, different kinds of solar collectors, pumps, LTA elements, which also allow direct transformation and direct conversion of the heat energy, in this case, into the electricity. Also, a heat storage is included so that students will understand how we can also utilize the concept of the transformation of the heat into the chemical energy with a later recovery as a heat. And so now we will go to the next product, which is called Lexsolar Smart Grid Professional. So we already get familiar with the concept of the energy generation. However, we also need to take into account that the appearance of such a vast amount of the new energy power plants, and especially small-sized energy power plants, they somehow need to be integrated into the grid system. And this can be done with the concept of the smart grid. So what is actually a smart grid? It's an intelligent grid system which also takes into account the demand and power of the consumers, as well as takes into account the energy generated from the different local sources, how they can be joined together with the conventional power plants. It also takes into account when is actually this energy generated, because the production of energy in from the renewable sources strictly depend on time, as well as the weather conditions and so on. So when we include all of these parameters, we can later combine it and use as well as for the training for TVET. That's how our product came by, which is called the Lexsolar Smart Grid Professional. So the students at first they experience the problem with also to develop some approaches which can be solved by using this experimental system. So they can generate and they can simulate some of the real life situations, like for example comparing conventional grids so conventional grids, conventional power plants with a more complex and more smart grids with some integrated renewable energy sources as well as some energy storage technologies. They can also control it, they can simulate such scenarios when, for example, a part of the household or one household is supplied with electricity only produced from the solar cell or windmill. Also, they can simulate the scenarios, timing scenarios, and so on. Also, they can understand how to integrate an e-mobility devices such as an electrical cars into the smart grid system. And now my colleague will also demonstrate you a couple of experiments in this area. So run it.
Okay, let's talk about smart grid. The topic of smart grids is very complex and the single topics can add up very quickly, you will see. At first, this is the experimentation kits. You notice there are 2 Lexsolar base units now, and we will definitely need them. These are the single components. Again, we have a solar cell here, we have a wind machine for wind experiments here. We even have a reversible fuel cell, which we can use as energy storage. And for now, I want to show you how the grid structure look like. So again, I will use my base unit. So let's assume we have a normal bureau inside Bangkok, and we had some consumers there. For instance, these light bulbs there, which can stand for some computers. And these computers are powered by fossil fuel power plant. Yeah, this is our power plant there, the power module. And this power module will use the electricity given by my fossil fuel power plant. And I will trace the energy I use with this smart meter. Smart meter is a little different to the AV module I already shown you. The smart meter is capable of showing me directly the power and the power per second, which is drawn by the light bulbs, the computers inside my building. And now I can power up my building. Using fossil energy. You see, the light bulbs are shining, my building is running, and I see how much power I use and how much energy per second I use from my oil or coal power plant. And now someone in the office building is switching on, for instance, the air condition. Air conditions another consumer, and with this consumer, the power which is needed for my whole bureau building is increased, and the energy per second is also increased, and I can track that with this experimentation setup. So this is the old grid structure, okay? Fossil fuel power plant, and the energy is drawn directly from burning coal in oil, and I can run my bureau building with it. Okay, now let's add up some solar energy into our bureau. We will use this solar module again, which is the same one as in the PV Professional. On the one hand, I have my solar module. I will take another smart meter so I can track the energy. And I will connect it to my building. And of course, I have another sun built into my Lexola Smart Grid Professional. And now I can track the energy from my fossil fuel power plant and from my solar power plant. I will show you I can power only with my power module, and I can add some solar energy here by switching off my sun. And as you can see, if I turn off my power plant, the building is still running. And if I turn away my solar cell, the building is still running by my power plant. So I have two components giving power to my building. And I can even simulate some sunrise. You see, I'm using my solar cell, and when the sun rises up, solar cell gets more and more shining by the sun, and I can even simulate this by just turning the solar cell. And now our whole building is powered by solar power, and if it's cloudy, I can power my whole building with the power module. Okay, now I want to take the whole experiment a step further. I already told you I have a second base unit, and now I will use it. Let's assume we have not only fossil fuel and solar power plant here. Let's assume we have also wind energy. Yeah, wind energy usually somewhere outside of a city, yeah, maybe even offshore. And I am able to use the wind turbine just like the wind turbine in the Wind Professional. So my wind turbine, yeah, is somewhere out there. So I have the possibility to use these power line modules. These are PTC elements, just simulating my copper power lines, given my energy from the offshore power plant to my building in the middle of the city. I will use an AV module again and trace down the power given by the power plant. And I will add up a storage technology. In the PV Professional I have the possibility of using this capacitor module, and I have the possibility to use this reversible fuel cell which runs with hydrogen. Okay, now for this experiment I will close the electric circuit. So this is my wind power plant with storage technology, this is my solar power plant, this is my fossil power plant. This is my bureau building somewhere in this city. So now let's see what happens when I'm turning off on my sun. See, the inner resistance of all my components is so high that the solar energy at first is not high enough to power my building. The solar module in this case is first charging up my capacitor module, and then my building is operating. And you see, the voltage is so high, not only my building is operating, the energy coming from the solar module is also going into the other grid I've built up here with my wind turbine. So the wind turbine is now actually run by the solar power plant. Now I can turn off on my power module, so I have now solar power and my fossil energy powering my building. And now I even could add up my wind energy, and I would use so much energy that I'm at risk of an overvoltage of my grid. So this is what a really smart grid comes in. Yeah, a smart grid needs to regulate where the power comes from and when do I need to shut on or shut off some of my power plants. So with this setup, the student can simulate a very complex topic by using only some components of our Lexolar Smart Grid Professional. So as you can see now, the energy stored in the capacitor module here lowers, and my whole grid structure gets lower and lower energy. So I'm at risk of under voltage now. And I will power it up again using my power module. This is what the whole over and under voltage and smart grid topic is about.
Thank you, Roman. We already get familiar with the concept of producing energy and energy distribution. What will, however, happen if our power plant is located somewhere in a desert? If it's like a solar power plant in a really remote area, or it's a wind farm offshore, standing way offshore. Then we probably need to think about the concept of the storing energy, electrical energy. And in this case, we have a couple of ways how we can do it. One of the ways storing the electrical energy storage is converting it into the chemical energy. One of the examples is electrolysis, so when the voltage is applied to the water in order to split it to the molecular oxygen and hydrogen. And the hydrogen can later be used in the fuel cells. Lexolar Hydrogen Professional, or H2 Professional, offers the entire spectrum of the fuel cell technologies for the technical application. A solar module, electrolyzer unit, and a fuel cell also permit the students assembling and examination of the complete solar hydrogen green cycle. So, because most of the hydrogen nowadays, they are still being produced from the natural gas by steam reforming. So it's one of the ways how we can also generate a completely green, let's say, hydrogen. Also, a working principles, efficiency and characteristic curves of the electrolyzer and fuel cells are just some of the experiments that students can perform, and just some of the topics which are covered. So besides PEM, or a proton exchange fuel cell PEM membrane, there's also a second fuel cell technology included, which is ethanol fuel cells, which can be also used in order to generate some energy. And with the help of the hydrogen charger and hydrogen metal hydride storage, one can easily generate and store the molecular hydrogen. So for later use it in the fuel cells. Of course, our energy can also be stored in a traditional way, so in a batteries, in a primary batteries, or non-rechargeable, or in secondary rechargeable accumulators. And there are lots and lots of different technologies which are available right now on the market. However, the question still remains, what application needs which battery type? So what capacity does a battery needs to have? And what loading performance can be also used to guarantee its long durability as well as long life cycles. So due to the problems of storing renewable energies, these are the questions which also needs to be answered in technical training. So with the Lexlar e-mobility professional, characteristics of different battery types, battery chemistries can be analyzed. So in addition, this kit also helps students to find out more about technical applications, so exactly which battery type can be used for this particular application and that. So the kit comes with 6 different battery types, namely nickel metal hydrate, lithium iron phosphate, lead, lithium polymer, nickel zinc, also with capacitor, so to compare two different technologies, or not just the battery chemistries, but also technologies, and as well as a fuel cell, a reversible hydrogen fuel cell. So the students will also get an understanding of some basic parameters which are important for the batteries, also get familiar with the charging processes, so for example, which battery type uses a CC or a constant current, or CV, which is a constant voltage profiles, and how also these battery types can be later integrated with the e-mobility devices or electrical cars. And now my colleague will also show you a couple of examples from this product.
Okay, now let's talk about e-mobility and the possibilities of storing electric energy. Within the e-mobility professional, we have the possibility to investigate the charging and discharging process of different kinds of storage technologies. We have here a lithium polymer accumulator, which is built in many mobile phones and notebooks and laptops. We have a lithium iron polymer accumulator, which is used in electric vehicles, for instance. We have a nickel zinc accumulator, which is kind of an old accumulator technology. We have a single cell nickel metal hydride accumulator here, and we have a triple holder for this battery type. Also we have this lead battery, which is used in normal cars. And of course we have again our reversible fuel cell to show the storage possibilities even more. And we have a capacitor module again to compare the capacitor and the reversible fuel cell. Now you see we have an AV module again, we have a digital multimeter here for measuring purposes. We have some resistor modules here which work as consumers. And in the end we have our small electric vehicle here, which can be operated with all different storage modules. Let's see what's inside. Now I want to show you how I can charge up and discharge my different accumulator modules. Again, I need my Lexlar base unit and I need an accumulator module. In this case, we take the single nickel metal hydride module, and I will track the charging process with my AV module and my digital multimeter. Here. Now, charging process works differently on all the different kinds of accumulator modules. The operating range of a nickel metal hydride accumulator, like this one, is from 1 to 6 from 1 volts to 1.6 volts. the lithium polymer accumulator here works from 3 to 4.2 volts. Means I need different charging current and voltage for every accumulator module in my experimentation set. For this purpose, Lexola developed this charger module. Charger module has a software behind which tracks which accumulator module I will load, and it tracks the charging status of the accumulator module. I can just pick which accumulator module I want to charge and say okay, start. Now the charger module will track the charging status of the accumulator module and will charge it up either with constant current or constant voltage mode. If I would make a mistake and use a different kind of charging program, the charging module would tell it to me by beeping in a very high tone. So with this setup I can charge all my accumulator modules, including the reversible fuel cell here. This is one thing I also wanted to show you. The reversible fuel cell Lexola works with distilled water or deionized water. Can just pop off the bottom. I have distilled water here. Load up the reversible fuel cell and replace my nickel metal hydride accumulator. Live it around, and this is the way I can now charge up my reversible fuel cell. I just have to pick up the electrolyzer program and now it will charge up the fuel cell. It may take 5 to 10 minutes and the fuel cell can be operated with. So now I made a small cut to let my reversible fuel cell charge up a bit. I will turn off the charging process. So this is the electrical reversible fuel cell. You see the distilled water has risen up here, and down here I have my hydrogen. Now I could use, of course, my resistor modules here as a consumer and track the voltage and the current over time by discharging my different accumulator modules, or of course I could use my small electric vehicle here, and this is what I'm going to do now. So I just put the reversible fuel cell on top of the electric vehicle, and now you see this is how it works.
Thank you, Ronald. The world is turning to electrical transportation to reduce the amount of the greenhouse gases. And the trend towards electric mobility is going to change the automotive industry almost completely. Because the new vehicles, on the one hand, they require completely new and innovative components and control systems, and on the other hand, they also need some changes in the business model, services provided, even in the people mindset, especially when it comes to the distance travel or charging times of the electrical vehicles. And one way how we can achieve it is, of course, to provide a high quality training and education in universities and vocational schools. And with Lexolar mobility instructors, students can gain a comprehensive knowledge of the state-of-the-art electric mobility system, as well as underlying concepts and control systems and components, like, for example, batteries or battery management systems, working principles of the electrical engines, water recuperation, how it can be utilized in electric mobility systems. These are just some of the topics which are actually covered by this educational system. And of course, on top of that, students can always drive it and enjoy the process of driving. And besides, the system can also be used not just while driving, but it also can be installed on the platform in the lab, and most of the experiments can be performed within the lab. Here you can see the main technical specs of the vehicle, and there is just only one thing which I want to emphasize, is that thanks to the pre-installed dashboard, so the built-in dashboard, we can always remotely control the thing, so while it's staying on the platform in the lab. And now we will see a video with a couple of examples of the cart in action.
นี่แหละค่ะภาพของพลเอกประยุทธ์จันทร์โอชานายกรัฐมนตรีนะคะที่ได้ลองขับขี่ยานยนต์ไฟฟ้าต้นแบบของนักเรียนอาชีววิทยาลัยเทคนิคสัตหีบจังหวัดชลบุรีที่ได้รับงบประมาณสนับสนุนจากภาคเอกชนแล้วก็มีการนำมาแสดงในทำเนียบรัฐบาลเมื่อเช้านะคะก่อนที่จะมีการประชุมคณะกรรมการนโยบายการพัฒนาระเบียงเศรษฐกิจภาคตะวันออกหรือว่า EEC โดยนายกก็ชื่นชมความสามารถของเด็กนักเรียนนะคะบอกว่าเป็นสิ่งที่รัฐบาลอยากจะเห็นแล้วก็ขอให้พัฒนาต่อไปในอนาคต
Now we are coming to our last products, namely the biofuel ready to go and bioenergy ready to go. The production of biofuel in Malaysia, Philippines and Thailand rose to 5.6 billion liters per year, and IRENA estimates the combined number of workforce in the three countries of 261,000 people already. It is especially important for the Thailand, since the Thailand is right now in the top 5 biofuel producers all around the world. And our products cover the entire process of the producing biofuel in a form of students experiments. So the experimental system includes all of the necessary components and covers such topics as a source selection for the biofuel production, so distillation of the resultant mesh, alcohol fermentation with later utilization of the bioethanol in the fuel cells, and also complete energy balance of the whole system, as well as the production of the biofuel. So not just a bioethanol, but also a biofuel by transfer esterification of the fats. The next one is a bioenergy. So in this case, we can also establish and completely see the process of the biomass formation and its utilization. It also gives students some concepts of the agriculture and hydroculture, urban gardening, and they can observe the complete process from sprouting the seeds and growing the plants up to the utilization of the biomass for heat and producing of the biomethane, also producing hydrogen for its later detection and utilization in the fuel cells. They also get the concepts of the artificial growing, so using artificial conditions like hydroponic setups, so which kind of light spectrum one needs to use, so what's the importance of the fertilizer, so what's the best composition of the fertilizer, and which also allows in exploration of the energetic use of the biomass, and follows once again the complete process from the sprouting the seeds up to the degradation of the biomass by compost.
Thank you, Dimitri, thank you, Ronald, for this interesting introduction and overview about the Lexolar products. But Lexolar not only offer and produce hardware for new energy trading systems, we are also a provider for services and academy products about this kind of technologies. And with these products we cooperate already with a lot of different partners here in the home province of Lexolar in Saxony. And to give you some example, you see on the slide just now, for example, BMW or Volkswagen are one of the major providers in the automotive sector, and they have already here in our home province a central base for the electric mobility. That's mean why we have also a very close direct link to the mobility sector and also need this education. Well, already also some education partners and science partners in the research areas. We cooperate with different universities here in Dresden, with Technical University of Dresden, and also with the Hochschule für Technik und Wirtschaft in Dresden. Well, but that you have an imagine which kind of topics you would like offer an academy service. I give you here an example. That is our Lexolar Academy. It's running completely 3 weeks with different main topics. One main topic can be new energies in use. Second topic can be electric mobility, and last topic is a combination of excursions and education to understand how an economy change from a carbon-based economy to a new energy economy. Because that is here in Saxony a very good example how this challenge can be worked. Well, I'm very happy that you follow us up to now with our interesting virtual workshop today. We're coming now to the end of this long journey, and I would like to attend you that you wait. We have in a next time that's a question and answer session that our colleague Dimitri also available together with Mr. Komate from TVET Technology to answer your questions what you already have to our products and services. Sawadee Krap, and I wish you a nice day.